So I always didn't have scale problems. Actually, I installed the first access point at the University of Pennsylvania back in 2000. Grew that network to a little over 4,000 before I left there and started working at Comcast in their Xfinity Wi-Fi program a couple years ago. But when I was at University of Pennsylvania back in 2008, it was interesting because we had an RFI bake-off process where we were trying to, I was reluctant to get rid of my fat APs and go to where everyone was, a controller-based model in the industry. And as part of our process, we were soliciting feedback from other universities on their deployments from some of the finalists that we were looking at and how things were going. And one of the most interesting answers I got was from the fellows at CMU at the time. And they basically told me that both of the vendors they were dealing with at the time were okay, but the hardest part that they had was supporting 2 different vendors at the same time on their campus. And now that I sit here supporting 9 million access points with 5 different vendors and all sorts of different models, I wholeheartedly agree with them. So if I'm going to talk about scale, I have to say that first, there's a couple things that we need to think about. Monitoring. These are some key elements. I mean, you always need to know what's going on in your network, no matter what the size is. That's very important, and I'm going to circle back to this in a second. Second is automation. I mean, you do need to know what's going on in your plant. I mean, you'll have schema for making sure you have accurate lat long, how you deploy things, spreadsheets. I mean, you know, that stuff's just gone by the wayside, right? You need automation for everything like that. You need any type of, when you're dealing with support calls at this scale, you need self-healing, you know, because the last thing you want to do is have 1,000 hands in the cookie jar and everyone's going off in a different direction. So this idea of self-organizing networks, or SON, is a concept that's well established in the world of LTE. In fact, you might hear terms, if you looked it up on Wikipedia, for things like configuring network elements and operating performance, and provide these self-healing capabilities in case of network interference or faulty network elements. I mean, to me, that honestly sounds like it's a catchphrase that management says, go make that happen and figure it out, right? So let's do that exercise. Let's figure it out. Could something like this happen? You know, we've been pitching this plug-and-play idea with the controller-based architecture for years. Can we scale that? Can we scale it to 1 million access points? Does that make sense? Can we do it in a multi-vendor environment? So let's shrink the problem down. Right? Let's simplify. This is, you got to keep it simple. This is what we're trying to figure out here. Let's say that it's easy to get Wi-Fi out there, millions or hundreds, thousands, whatnot. I mean, like, we're all dealing with tons of access points out there. But can we manage those radios well at scale? So let's say I build a framework for this. Let's say I'm going to read in some key network elements, some data from these radios, assess how it's going, and then, you know, maybe do something about it if I think I could change and definitively say I might make this experience better. Now, I want to be careful not to say, hey, I want to build this giant framework for all these APs, and all I'm basically is a expensive channel change and power algorithm. So that's not what I'm thinking about here. What I'm thinking about is some of the stuff that, you know, was in the 802.11k standard, and some elements that, you know, all of us have been dealing with on a regular basis to say, okay, I'm going to troubleshoot a problem. What's the data, and what I need to basically assess what is going on the network? Well, I'm a network engineer, so I'm always going to be all for client interface statistics, right? So just retransmission errors, TX, RX, the basics, right? I mean, like, that tells you a multitude of things that are going on in the network. It's the radio we're talking about, so I'm going to want to know about activity factors. Like, when am I going to reach that energy detect threshold? When is there the clear channel assessment? When am I going to know when a radio was too busy serving clients, or the noise floor was too high, or client RSSI was, you know, just, you know, reached a certain threshold, right? So we can debate these for some time. But let's pretend that that was the easy part. And I will be happy to take this debate offline with anyone here, because I think it's a very interesting discussion on what to capture. But let's say we figure this out. We set up this framework. We start reading in elements. Now, I'm talking a multi-vendor environment here, right? So we got to default to the lowest common denominator on how to grab this information. OK, I think most access points out there can support SNMP, right? Let's say we poll every hour, every 5 minutes. I mean, can you imagine collecting SNMP statistics from over 1 million access points every 5 minutes? Does that sound reasonable to you? Is it manageable to scale, to pull, and to store that information in a central repository? Does that even make sense? All right, so these, we could debate this for a long time as well too, right? So let's say we draw the network and say we're going to do this once an hour. We're going to collect these statistics. Okay, we've got to keep simplifying this right now. So now we're building this framework. So why don't we take a page, so how do we measure, right? So I've had to do a ton of home improvement projects over my lifetime. Measure twice, cut once, right? I don't want to make any changes, but right now, let's just try to figure out, let's assess that situation. Okay. Well, the LTE and everything that we're doing within the cellular industry is basically always had this wireless mean opinion score. So let's take these statistics, let's do a little algorithm, let's do some shifting, and let's figure out how we can basically assign a score to this. So, okay, now we have a score, so we can assess how the radio is going. We can see we have some visibility. Well, I did mention that we're talking about different vendor types, right? So now, not all of them use the exact same statistical counting, either due to equipment type or chipset. Is there an apples to apples comparison? Can we simplify this? How do we translate this into different deployment types as well? Can I reasonably compare radio resources for the same way that in people's houses or to multi-dwelling units to venues? That doesn't make any sense. I mean, it's Wi-Fi, but it's not apples to apples. I mean, the majority of the clients will still be similar that are out there, right? But we're not doing the same usage patterns in all these different areas. So as I start to think about all these cases, this also just starts to get just more and more difficult to try to put these into some buckets to say, hey, this is what it is, and scale this. Okay, so here I am pitching the idea of the self-organizing networks for managing RF at scale, but this might still be something that's in the future, something that could be a standard, something that we might look to in the future. But I think the key takeaway here is some of these metrics that I identified, or that all of you can identify here. And I think the important part that we need to think about and discuss is knowing what is on our network and being able to understand. That helps us make the decisions to do any type of analysis, predictive, put things out there, disable some radios, anything like that. And that's the information that helps us keep the lights on a network of any size. So I'd be happy, since I wasted so much time with this, I'll be happy to debate some of this stuff offline with any of you. There are less than 10 females here, so I'm sure you'll be able to find me. Thank you.